All right. Yeah, so I'm Dave Jaffe. I'm talking to you from the campus of Stanford University. And the title of this talk is Engineering Design Process for Producing Outstanding Assistive Technology Prototypes. What I've been doing at Stanford is teaching a course on assistive technology for the past 15 years, and I'm getting ready for my 16th year coming up in the winter quarter. So go on to the next slide here. Yeah, so a little bit about me. I went to University of Michigan, undergraduate in electrical engineering, and for grad school, I went to Northwestern University, just north of Chicago, in biomedical engineering, and that's a picture of me when I was 22. I looked look a lot different now, but my first job was at the VA hospital just outside Chicago, where I was a biomedical engineer, and we had a group of people who maintained all the medical equipment in the hospital. And so that was a good background for me to see how people use medical equipment and how they abuse it, and learned how it worked and stuff. So that was a lot of fun. Then I came out to California. I worked at the VA in Palo Alto, and this is the building that we had, Rehab Research and Development Center, where we looked at high-tech solutions that benefited veterans with disabilities, and we worked on a lot of very clever and interesting projects there. I won't be getting into that too much today, but here's what the hospital looks like now. And then I moved over to Stanford about 15, 16 years ago, where I've been teaching my course, which is called Engineering 110. The name of it is Perspectives in Assistive Technology. And I've also been involved in a number of other courses, helping students with their projects, and even some students who are working on their own on assistive technology projects. Okay, so a lot of presenters have a slide, 5 numbers that define me. So I decided to give that a roll. So I first arrived in California November 11th, 79. So that was 42 years ago yesterday. And that's when I started working at the VA. I've been teaching the course, as I said, for 15 years. And last year, the course was virtual. So all the meetings I had with individual students were virtual as well, because a number of the students were, outside California in other countries, and sometimes it was in the middle of the night for them. So I met with students at other times. So I had 103 Zoom meetings with students last year over 10 weeks. Last year, despite the course being virtual, I had 43 students enrolled in the course. And the year before that, when it was in person, I served chocolate chip cookies to all the students. And in 2020, I served 957 cookies. So I wish I could give you all a cookie right now, but got to figure out how to do that virtually. So save that for another time. So I'm going to be talking about the engineering design process. So this is the process that I use for my course, and I'm going to be talking about elements of it. Who are the people involved in it, and all the different pieces of it. So that goes through most of it, and at the end, I'm going to be talking about how do you commercialize a product, and then Grace wanted me to talk a little bit about assistive technology courses that you might expect to find in college, and maybe even careers in assistive technology. So that's the plan. So, people, ask me, what is the design process? So this process is just a way of organizing your activities, and that's done by people who are makers, designers, or engineers, and they do that to achieve a goal because using a process, a structured process, with individual steps increases the chances of succeeding in the goal. And if you're a student in my class, that's what I expect from students. So if they do that process, if they go through the process, they do a good job and they get a good grade. If not, their project suffers and maybe their grade will suffer as well. So design processes have names, and here are some names that I came up with. At Stanford, they have what's called the D School, where the D stands for design. And so the name of their process is design thinking. But it's basically a non-engineering kind of process. At Northwestern, where I did my master's degree, they use a term called whole brain engineering, which seems like a very strange term to me because I go around with my whole brain all the time. So I don't understand why they did that. Other kinds of name designs: human-centered, user-centered, participatory, empathetic, compassionate, co-design, cooperative design, and bystander designs are some of the other name processes that I've heard, but they all involve the same core thing, and that is doing something, testing it, seeing what worked and what didn't work, and then repeating the process to refine your prototype until the time or the money run out. So that's what we mean by design process. So this top graphic is what the D School uses, and yeah, I don't necessarily go by what they do. So there are all sorts of various variations of the design process, depending on what you're doing, the environment you're doing it in, and what your goal is. So, certainly there's a design process for my course. Certainly there are design processes for other project courses at Stanford that may look a little bit different in the specifics. And certainly the design process changes if you're working in an in-person class or a virtual class. In a virtual class, the people working on the project may be dispersed. They may be in different parts of the country rather than all being on campus. You could be using a design process for the class project, or if you're doing something independent of a class, you can have a different design process. Are you doing this project as a team with other people, or are you just doing it by yourself? Are you doing it with a person with a disability and an older adult? And if so, are you working with a real person, or are you just imagining a person with a disability? That makes a big difference. Are you trying to solve a specific challenge that they have, or you want to do something general, like I want to do something that will help all people who are blind? That makes a big difference as well. And why are you doing it? Are you doing it just to build maybe something, a prototype, a functional prototype that will help somebody that you know, or is your goal to come up with a commercial product? Those are two very, very different design process variations. Are you doing it just to learn about a particular topic or challenge? Are you interested in practicing your fabrication skills? Or you just want to come up with a CAD design that you can show people? Are you building maybe a physical model, an appearance model? Are you doing research on a particular topic, or you just want to write a report about a specific technology? And of course, your design process will vary a whole lot depending on what your resources are. Do you have how many people you're working with? Are you do you have access to the tools you need, to a laser printer, a 3D printer? Are you working in your bedroom? Are you working on campus? How much time do you have to do the project? Are you doing it as a part of a 3-day hackathon, or Is it a course of 10 weeks, 17 weeks? Maybe it's a course of nine months. How much money do you have in the budget? How much can you spend on your project? All these things influence what your design process is. Okay. So let's go back and maybe talk a little bit about what assistive technology is. And your first idea is that assistive technology, having the word technology in it, you think of something physical, you think of a product that benefits somebody with a disability or perhaps an older adult. But in my thinking, it includes not only devices and products, but services, policies, all the people that are involved in it, and the facilities that the work is done in, like a school, even in Congress, is a possible facility. So all these things I've listed over here are examples of assistive technology that you might not have considered. So, I can only walk at about 2 or 3 miles an hour. And for me to get from one place to another place, I'm going to need something besides my legs. So I'm going to, get into my car, take a bus, take a train. If I want to get across country, I take an airplane. So these enhance my abilities, and these are a part of my definition of assistive technology, because, without these things, we can't get, the job done. In this case, it would be mobility and transportation issue. And the same thing, applies to communication. When I talk, people maybe only 6 feet away can hear me, but I want to talk to other people. So I'm going to need things like my phone, computer, the internet, Zoom, to talk to people further away, because I don't have an inherent ability without this technology to do that. And certainly if you've ever been without electricity or your cable, or you lost your phone temporarily, how much of a pain it could be to just live a normal life. And certainly robots, help people do things that they, couldn't do on their own, as far as like lifting things or moving things. But the biggest piece of assistive technology in my mind is the educational system. And so to my students, I say the #1 piece of assistive technology is Stanford University, because, without, places of education, you wouldn't, have intelligence. You wouldn't be able to learn about things and to help other people. So the education system and schools and universities are indeed assistive technology, because, without them, it's hard to learn on our own. And one more thing that I want to say about assistive technology is that you can abbreviate it as AT, but please don't evaluate it as assistive tech, because, you don't want to have an abbreviation for just the technology part of that. And it doesn't make sense to abbreviate assistive. So you can call it assistive technology or AT. And if you use anything else, that's not very professional, and people will understand that. Okay. So a little bit more about me. As I mentioned, I have degrees in electrical engineering and biomedical engineering. I've done research. I've been doing teaching. And so I have this background in assistive technology and in design process. But as an engineer, the way I think is as an engineer. So I don't apologize for that. It's just the way I am. So I have a certain philosophy and ways of thinking that are based upon my engineering background. And this certainly comes into play when you're talking about building prototypes with people with disabilities and real people. And I really like to use terms that are quantifiable. So my #1 worst term in my mind is innovative or innovation, because there's no way to measure it. So if I tell you, I want you to go into the lab and innovate for 2 hours and come back to me. What would you do? What if your boss says, I want our next product to be 20% more innovative than our previous product? You know, that's it. There is no terms to quantify that. So for me, it's in the same realm as the words nice and cute. So when I think about when I read about innovation and being innovative, I look at it as not an engineering term, but a marketing term. So you'll see all kinds of ads that say, you know, our product is innovative and stuff like that, but it has basically no meaning to somebody in engineering terms. So other people that play a part in the design process are people with disabilities and older adults. And so you can call them users of assistive technology devices or just users. Another term is project partners. If you're working with an agency, then the people that you're working with are called clients. If you're doing human research, then the people that you're doing research on are called subjects. If you're in the medical field, the people that you're working to help are called patients. I don't particularly like the term co-designers because in my mind, you know, the terms like co-pilot and co-star, you know, mean that all the people that have that designation all do the same thing. They have the same background and skills, and that's not necessarily true of the people that work on assistive technology projects. So the shortest term, best term to use is maybe users, okay? And the most important thing to understand about people with disabilities and older adults is that they are all individuals. And by that, I mean the goals that they have for themselves, the challenges that they might have through their disability, and the struggles and the obstacles that they encounter are all personal. Any one person has, you know, the whole set of different goals and challenges than other people. So you cannot think of people with disabilities really as a group because they are all different. Older adults the same way. Everybody is an individual and different and have differences. So people with disabilities can certainly describe, you know, what's bothering them, you know, what as far as their disability and how it affects them. So you can get that information from people with disability. But you know, these folks may not have a background in engineering. They may not be able to do any design. They may not know what fabrication is. They may not have done any of this stuff. So you know, they cannot typically play a role in these activities. And you might think that a person with a disability might know everything about their disability and everything about products that might help them with a disability. That is not true. People with disabilities may only be aware about the stuff that they use and about the problems that they still have using those devices. It would be, and in the same way, you may be given a challenge then by a person with a disability, and you may think that that challenge is unique. Nobody else in the history of the world has experienced that, and that it's up to you to solve that challenge. Well, that is not true either, because for every challenge that there is out there, it's happened before. Perhaps there's dozens of products that already address that challenge. Whether or not they'll work for that particular individual is another question. And the last thing, which is really important for you to know, that if you come up with a solution for a particular person with a disability, say like you make a lap tray for somebody who uses a wheelchair, that lap tray may not be suitable for the next person who uses a wheelchair, because they might use a different kind of wheelchair and it may not fit, or a person might say, oh, I want to have something that collapses. I want to have something that folds up on the side. We've done a lot of projects, student projects that involve lap trays, and no two of them were the same. So even something as simple as a lap tray may not be generalizable for a large number of people. So you need to keep this all in mind when you're working on your projects. Another player in the design process are your instructors, the organizers of the program, and people that help you as project coaches. Okay, and the last player are you guys, the bright, enthusiastic students. But you may lack a full knowledge of assistive technology, and you may not have a lot of experience building things, or in mechanical engineering, or know about mechanical systems or different kinds of materials and stuff like that. So you can be called team members or project participants. Okay. So the first part of design process is identifying a problem. Okay, and you need to do this because you've got to have something to work on. So what this problem identification is, it's just a very concise way of describing the problem and challenge you're going to work on. And you do it in a way not to mention the kind of solution you're envisioning, because you don't know, how you're going to do that. You don't know what's going to work at the beginning. So it's very important to describe it in a way that doesn't mention the solution. So as an example of that, this is Austin here, and he's a Stanford student. He's a wheelchair user, and he has a spinal cord injury, and this is what he proposed as a project last year. So let me read it, and I want you to understand, why this is a really suitable description of the problem. He says, one of the more frequent problems I run into is using a knife while cooking and food preparation. As a result of my spinal cord injury, my grasp strength is very weak, presenting problems in my practical ability to cut things with a knife. So that's perfect kind of thing. That's the problem identification. Perfect. And so what you want to do with the problem identification is actually construct a project description, and this should be written down someplace so you can refer to it. I write this down, and this is how I present problems project to students. And so each element, each project has a title, so there's just a short way of referring to that project. The background in this case might be a background about who Austin is, his medical condition, what kind of assistive technology he uses now, what kinds of things he might like, a background of him as a person. It might also include a little description about what spinal cord injury is, and so on. And the problem part is just the problem statement that Austin stated. And that's sufficient to describe the problem, at least at the beginning. And the aim is also very succinct. The aim is explore designs that would solve Austin's problem, okay? Another part of the project description is the design criteria, which I'll get into on the next slide. And the last thing I include in my project description is, links to, maybe things, maybe, Austin's webpage, or maybe something about spinal cord injury, or maybe about, maybe there's a website about cooking with a disability. And these are things for students to refer to get some information. Okay, so this is what the students came up with. There were two students. The student who built the design on the left came up with a handle that Austin could use. It's thick, so he can grasp it even with his weak strength that he has. So it's made out of walnut, and it was stained and stuff to look really neat. The one on the right is something that Austin wears around his wrist, and it has a knife attached off to the side, so he can use that to, cut an apple or whatever. So these were the solutions that the students came up with. Design criteria is just merely a characterization of the solution. It should be things like, it should be, rugged, it should be strong, it shouldn't break, it should be easy to put on, take off, foldable, compact, all things like that. And maybe something more specific for the particular problem. So those are essential ones. So those are the essential things, are the ones that are actually required for you to address. The beneficial ones are the icing on the cake, nice to have, and that it may include, things like, personalize it, for the Stanford 49ers, because that's my team, and I want to have their logo on it. And, the design criteria, you also, need to be thinking about aesthetics. All the designs have to be, look good. You don't want to use something that doesn't look good. In fact, the more cool you make it, the more you might want to use it. And so the coolness factor is a huge issue that you may not be aware of, because not only for the device that you're making, but you want to be telling people, hey, I'm working on this cool project. And so your project has to have this sense of coolness. So in doing that, I said, well, give me examples of cool. So these are four cool individuals that I thought of in my life. And so I would, if this was a little bit more interactive, I would ask you to identify these people. So why don't you, if you want to, you can do that in the chat. So yeah, you may not be old enough to know some of these people. So the guy on the left is Fonz from Happy Days. So he was a really cool looking guy. He's got, this leather jacket. He drove a motorcycle. He was able to jump over sharks, which is where the term "jump the shark" came from. The guy second from the left is Mick Jagger of the Rolling Stones. And so he's a cool musician, but he's also an older adult now. And I think he's 80, which is just amazing. They just, played as a band a couple months ago. So he's still going strong. And Joe Cool over there is actually Snoopy, and, very, very cool person. He's even wearing, a t-shirt to identify himself as being cool. And of course, the one on the right is Bugs Bunny, who I've thought, from the very beginning, he was a, a cool person. Okay, you might have your own cool people, and you might include that in the chat as well. So think about that. So coolness factor is really important. It really comes into play, every day. If you're in the store, like buying, a shirt or a pair of pants, you're thinking in your head, is this something that I want to wear? Is it going to, make me look cool, right? And so you're deciding on a purchase on the basis of coolness. And people, base what assistive technology they buy based upon on its coolness too. And even if you're an older adult or a person with a disability, you still have this desire to be cool. Okay. Okay, this is the most important part of the design process. This is understanding the problem. So after you get the project description, you want to understand the problem. And that problem, could also be spoken of as a challenge, an obstacle, or a struggle. And what you want to do is learn as much as you can about the problem. And why do you want to do that? Because the more you know about the problem, the better your solution is going to be. You don't want to be in a situation where you build something, and because you didn't understand a particular part of the problem, your solution is inconsequential. It doesn't work. And you need to, have knowledge of of the problem, because that's a prerequisite to brainstorming, which I'll talk about next. So how do you understand the problem? Okay, well, the first thing you want to do is, if you're working with a person with a disability, you want to talk to them, you want to interview them, and additionally, you want to observe them. So the best kind of interview you can do is an in-person interview, and you could do it, in their home or in a common area or outside, so that you get, a very close understanding of the person. You may also want to talk to their family members, including their caregivers, because they will have a little bit different perspective on, what the challenge is and how it affects the person. You want to get background on the user, to find out, what they like, maybe even what colors they like or what they like to do. And maybe you want to get knowledge of the health condition. If they have a spinal cord injury, what are the limitations, the health limitations of that? And in working on the problem and working on understanding the problem, you want to do that as a team, because each team member might have a little bit different, might have different questions. Maybe not a single individual team member can do all the interviews, because they might have a limited repertoire of questions. And so if you can interview the user as a team, that really would help out. And when you're working on your project, you have to understand there's people that are more knowledgeable than you or the user with these. So you want to consult with experts. And so you want to seek out people who have a background in assistive technology or mechanical engineering or whatever your solution might encompass. And so you may want to consult with them. You may want to ask them questions about what you're working on and get some feedback from them. But you need to make your own decisions on this stuff. You can't have the user say, well, I want you to do this and that, and that's the only way to do it. And same thing with an expert. You should be able to get just information from them, and that information should lead you to come up with a decision on how to proceed. So in my course, if a student team says, well, I did it this way because the user wanted it done that way, that's not a good solution. I would actually mark a team down if they said that to me. So one expert that you know of now is me. I'm able to help you if you have working on a problem and you have a very straightforward question. Just email me, and I can probably lead you in the right direction. Okay, this next element is really critical, and I don't hear very many people talking about it. So if a person has a problem, what are they doing now to address that problem? Are they using some device which isn't working out well for them? Maybe there's other products on the market that the user doesn't know about or nobody knows about that may help. So a lot of times people say, Dave, here's the suggestion for a project. So the first thing I do is go to the internet and I'll say, search for, something that might be a search term for a solution. And typically I come up with pages and pages of products that are already out there that may be a solution. So why would you want to work on a solution that you might already be able to buy, and if you have Amazon Prime, you might be able to have the next day. But the more detailed question to ask is, if there are all these products out there, why aren't they part of the solution space? Why don't they work? Well, it may be that the user may not know about them. So if you're taking notes, write this down. Sometimes the only problem is the lack of an awareness of the an existing solution. Sometimes the solution is already out there, but you may not know about it. So you want to do everything in your power to make sure, that there isn't already a solution out there before you spend time and money on coming up with your own solution. It's not cool to copy somebody else. So don't do it. You want to come up with something that's creative, and maybe it's inspired by an existing product. So there may be something on the market that you could buy, but maybe if it was modified in a certain way, it will work a lot better for the user. So it's valid for you to buy something out there and adapt it to make it work better. So I have a term for that, and that is called aftermarket functionality, where you buy something and it may not be an assistive technology product. It may be something that helps everybody, but maybe you have to adapt it a little bit to make it work for a person with disability. Okay. All right. So brainstorming is next. So now that you know as much as you can about the problem, you can imagine possible solutions. And you can do this as a group. It has to be done as a group. It can't be done individually, because you need that interaction between team members. And your goal here is to come up with as many possible solutions as you can without judgment. So here's a way not to do it. So if somebody says, oh, let's do it this way, and the other person says, no, that's no good, that's not going to work at all, that's not brainstorming. What you want to do is just take all these ideas, put them on the board or put them on Post-it notes, and just put them down, even though they may not be workable at all. But this isn't the time to do that. And what you really want to do, and that could be a lot of fun, is just suspend the laws of nature, the laws of gravity, and think about weird things like, well, how would they do it on Star Trek? How would Harry Potter solve this problem? So when you think about these weird things, that releases your brain, from reality, and gets you thinking about things that make no sense at all. And it's beyond that a solution might lie. So you need to brainstorm until everybody laughs at the solutions that you're coming up with, because you need to get out of the box. And that's how you get out of the box, is to think about the weirdest possible solutions you can. Okay. Well, after you got all those on the board, then you need to figure out which ones might be good to pursue. And the way you do that is you go back to your design criteria, and you say, for concept number one, how does it meet design criteria number 1, 2, 3, 4, and 5? And you can do that with all the concepts that you come up with, and then you can put them all in a spreadsheet and figure out which are the top 3. And also you need to think about other things, like how difficult would it be to come up with your concept number 2? How complex is it? What's it going to take to do that? And if it's too difficult or too complex, maybe you shouldn't be doing it. Maybe there's some solutions that might require years of effort, but you only have a month. So, you have to consider that as well. There may be design concepts that you may need special materials. And you say, well, I'm going to need a lathe and a drill press to do that. But, you may not have those tools available for you. You may be working only in your bedroom, and you don't have that stuff in your bedroom. So maybe that's not a design concept to consider. And of course, you also want to, apply aesthetics and coolness to all the concepts you come up with as well. So at the end of this, you should have maybe 1, 2, or 3 design concepts that you can move forward with. And the way you move forward with this is called iterative prototyping. So this is a very tight cycle where you design something, and it could be through a sketch. You fabricate something, and it could be at the beginning you need to do something really quick and simple. You need to use low-cost materials and simple ways of putting things together. So I recall a student group that I had, and they were working on a walker. And so their first prototype involved them cutting up pencils, wooden pencils, and hot melting them together in the shape of a walker. And so I don't know if they did that, just to have fun with me or whatever, but that's a suitable thing to do. So maybe the first thing you do is you build something out of cardboard or foam core, and you glue it together. And it's really important to have something physical because your brain works in 3 dimensions. You can take a look at it, you can point things out, you can turn it over in your mind and see, what might work and what may not work. So after you build something, you test it with the user, or maybe you test it with yourself. And during the test, you're going to evaluate what parts work, what parts didn't work. And so your first thing that you do is not going to work. So it's not a failure. It's not a failure if you learn something from it. So the idea of going through this prototyping is to get a deeper understanding of what's required, through these steps, which, really aren't failures. They're just, learning experiences. Okay. And so you go through the cycle multiple times, and each time you produce a more refined prototype. And you keep on doing that until, your time runs out, or you reach your goal, or you spent all your money. And in my course, the students go through like 3 to 10 prototypes in 10 weeks. So you need to do these things quickly, and you need to understand that building something isn't a linear process. You can't say, I'm going to build 10% of it the first week, and the next 10, each week I'm going to build another 10%. That's not how things work. In a lot of cases, you build something, and all of a sudden you understand, this design concept isn't workable at all. So you may have to go back and pick another design concept to deal with, or you might reevaluate what the problem is. That's happened too. So you just start over again with a new understanding of the problem. And in doing this, you have to have a contingency plan. What if my last prototype doesn't work? Well, you always have the previous prototype to show. So if your project is due on a certain date, think about if if it doesn't work out as planned, what would you do? So that's a part of the design process, having a contingency plan like that. And of course, what you want to be doing all through this is, let me go back here. Yeah. What you're doing through all this is, is testing it with the user, because they're going to be the ultimate person to use this. You want to get feedback from them. You want to get suggestions from them on how things work, how things didn't work. And this goes into your redesigning. And if you're doing this in a virtual way, you can do it over Zoom. You can show somebody. You can maybe simulate it with yourself or your teammates. And basically, the reason you're doing this is because you're measuring something to show that your solution is better. So if you come up with a device, you can say, the user was better able to use, this is a better solution because it took the user less time to do this activity, okay? So you want to measure something. As an engineer, you always want to measure something. So think about something to measure, even if it is time, okay? Very important. Testing with user. Another very important and necessary part of the design process is reporting. So you want to document your efforts. And how do you do this? Well, when you're going through this iterative process, you're going to have sketches, you might have CAD designs, you want to take photographs of what you're doing. If you take a photograph, with the user, you take a photograph of your prototypes, you may want to take short videos of your user using one of your prototypes. That all comes in very handy for your oral presentation. So you want to be in front of, your class, and explaining, what you did with slides. And you want to do this in a very formal, professional fashion. So in my mind, I want students to think of themselves not as students, but as pre-professionals. So the more you can do to behave and present in a professional manner, it's really important. And you're also going to be doing a written report, and you want to have that. You want to do a really good job on the report. Oral presentations and writing reports are things that take a lot of practice. So, in doing this project, it's a part of you practicing. Every time you do it, it gets better. And I want to tell you right now, this is another thing to write down on your notes. Having excellent communication skills is really important, no matter what profession you're going into. If you're going to be an engineer or something else, everybody is going to be, listening to you. You're going to have to present your ideas to people. You're going to have to be evaluating other people, evaluating their designs, and communicating. It's just really, really important. You're not going to be, in a lab sequestered, working on stuff. You're going to be out in the public. It's really important to learn how to do excellent oral presentations and written reports. And I really wished my instructors would have told me that, because I would be doing a much better job in this presentation if they would have told me that, when I was going to school. But yet I had to learn it on my own. So the last thing you want to do is to show off your cool project to other people. So you want to demonstrate it to other people, and it could be, the other teams or whatever. It's really important to do that. And you want to be able to describe it while you're demonstrating it as well. And you may want to get your user involved to show how the user, how it's a solution for the user. Really important thing to do. Okay, so now that you have, say that you've been through this process and you have this functional prototype and it's really cool, and you say, what are your next steps? Well, you might think, oh, this is so cool. I think everybody in the world's gonna, want this, so I'm gonna make it available to everybody. Well, how do you do that? So it's the process of commercialization. It's a very difficult process. The easy part is coming up with the first prototype. The hardest thing is coming up with commercializing into a real product. And that's maybe like for these kinds of things, maybe a 1 in a million shot. So the way it's done, in industry is that, there's a big demand for something, like an iPhone. So this, the company uses mass production techniques. They have, assembly lines. They have lots of people. They buy things in great quantity. Because when you buy 50,000 of something, it's a lot cheaper than buying them one at a time. So you want to have a lot of users to create a lot of demand so that you can build things that way. So looking at what Apple does, on the first day of announcement of a new product, they sell 1 million of them. But an assistive technology product, you're not going to sell 1 million of anything. There hasn't been 1 million of any product, assistive technology product sold. Even things like wheelchairs, maybe they sell tens of thousands a year. So it's not a mass produced kind of thing. One misconception that students have is they say, this prototype, it cost me just $50 to build. So that's going to be I can sell them for $50, on the market, but price includes things other than parts cost. In fact, for iPhone, the parts costs are basically, 1/3 of the price of the iPhone. In other products, the parts may be 1/10 of the cost. So you take the parts cost, multiply it by a factor of 10, and that's how much the retail price might be. So in doing a commercialization process requires a lot of time, maybe years, And maybe if you're building and commercializing something that is high tech, it may cost you millions of dollars, to get started, and years of time. And it certainly is going to require a lot of luck. One thing I want to talk about is product liability insurance. Say you're a company making like wheelchairs, you are liable for any, you might be liable for any injury one of your customers has with a wheelchair. If they fall out of it or something breaks, and you don't want to go bankrupt if somebody sues you, even though you build it the best you can, there's, things happen. You don't want to be sued, for, all the money that your company has made. So this product liability insurance, it could be a significant expense for a company, building high-tech assistive technology, high technology products. So a lot of people who are design assistive technology products, don't sell them. So what are the other alternatives? For students, you can take your prototype and enter a design competition. There's a bunch of them out there for students, and there's a bunch of assistive technology organizations who have student design competitions, so you can check that out. If you really want to pursue, making something, maybe at low numbers, you can do a GoFundMe kind of thing, but then you have to promise these people that you're going to build one for them. Okay, so you can find somebody who can consult you in commercialization, who's been through things before. If you have something that is really neat and cool, you may want to patent it. So that may take tens of thousands of dollars and maybe a year to patent your invention. But once you do that, then you own that invention, and basically you can don't have to commercialize it yourself. You can seek out other companies to commercialize it, and so they would license your design. So you would get money for your invention, but not have to do any of the commercialization stuff. So there's people I know that do that, that like building, like inventing things, but don't want to go through the commercialization part. If you're commercializing something, that's going to take up a lot of your time. Maybe you want to move on to inventing something else. So that's another reason. And finally, you can just put your solution in the public domain. And there are places to do that where you just upload your design and your papers, and other people can work on it as a do-it-yourself kind of project. Okay. So now let's go to college. Okay. Everybody, is going to college. I understand. I talked to a couple people. So what can you expect of assistive technology in the college environment? Well, there's lots of variation. There are certainly colleges that have no courses or projects dealing at all with disability or assistive technology. So you'd have to, take a look, online, at a particular college to see what they have. So in all schools that have engineering courses that are certified, there's a thing called capstone course. So it's basically a senior year project course where you work as a team and you build something. And the thing that you build may be something that's an assistive technology project. And there are some colleges that have capstone courses where all the projects are assistive technology projects. There are some that maybe one of the project is an assistive technology project. And certainly there are places like CSUN that have programs where you can study assistive technology. In other universities, there may be programs in assistive technology, or maybe you can do independent study, or maybe you can customize a major in assistive technology. So there's lots of programs around at the bachelor's, master's, and doctoral level that are called rehab engineering or rehabilitation science. And you can find assistive technology in courses that are in biomedical engineering or biodesign, bioengineering, biomechanical engineering. And there's even courses related to computer science, electrical engineering, mechanical engineering, and even medicine and law and education that may deal with assistive technology. Maybe not as in the design or development of assistive technology devices, but maybe in other areas like legal policy and teaching kids with disabilities or working with patients with disabilities. And finally, outside of engineering, there are a number of schools that have design courses that may involve assistive technology. So at Stanford, there's the D School, which is a design program. Okay, very popular. Okay, so what about careers in assistive technology? Well, there's a lot of things you can do, and you can certainly teach assistive technology like I do. You can work for a company and doing engineering and product design. Again, with a company, you can be involved in sales or marketing, or maybe at the government level, we can work on disability policy and advocacy, social work, education. There's all sorts of things in adaptive sports and legal issues as well that extend to assistive technology. In the research area, you could be doing research for a product, or maybe on techniques that will provide a way to provide rehabilitation to people with disabilities, coming up with new devices and things, and doing medical research. And there's also people that work on, okay, there are these assistive technology products out there, and assess how well they work for that particular individual. Okay. So that's the end. How did I do? Oh, God, right on time. Here's my contact information. So please feel free to email me, and very easy email address. And here's the website for my course. And the course starts in January. And if you're lucky enough to be in the Bay Area here and near Stanford, you're welcome to drop in and sit in on a class session. The course is not online this year, but some of the materials are, like the slides and stuff. So those are opportunities for you. So let's take questions at this point.